This is the ESOcast, cutting-edge science and life behind the scenes of ESO, the European Southern Observatory. Exploring the ultimate frontier with our host Dr. J, aka Dr. Joe Liske.
Hello and welcome to this special episode of the ESOcast. Leading up to ESO's 50th anniversary in October 2012, we will showcase 8 special features portraying ESO's first 50 years of exploring the southern sky. Great music, isn't it? But suppose you had a hearing impairment. What if you couldn't hear the low frequencies? Or the high frequencies? Astronomers used to be in a similar situation. The human eye is only sensitive to a small part of all the radiation in the universe. We can't see light with wavelengths shorter than violet waves or longer than red waves. We just don't perceive the whole cosmic symphony.
Infrared or heat radiation was first discovered by William Herschel in 1800.
In a dark room, you can't see me. But put on infrared goggles and you can see my body warmth.
Likewise, infrared telescopes reveal cosmic objects too cool to give off visible light, like dark clouds of gas and dust where stars and planets are born.
For decades, ESO astronomers have been keen to explore the universe at infrared wavelengths. But the first detectors were small and hence inefficient. They gave us a blurry view of the infrared sky.
Today's infrared cameras are huge and powerful. They're cooled to very low temperatures to increase their sensitivity. And ESO's Very Large Telescope is designed to make good use of them. In fact, some technological tricks, like interferometry, only work in the infrared. We've broadened our view to reveal the universe in a new light. This dark blob is a cloud of cosmic dust. It blots out the stars in the background. But in the infrared, we can look straight through the dust. And here's the Orion Nebula, a stellar nursery. Most of the newborn baby stars are hidden by dust clouds. Again, infrared comes to the rescue, revealing stars in the making. At the end of their lives, stars blow out bubbles of gas, cosmic showpieces at optical wavelengths. But the infrared picture shows much more detail. Don't forget the stars and gas clouds captured by the monstrous black hole in the core of our Milky Way galaxy. Without infrared cameras, we would never see them. In other galaxies, infrared studies have revealed the true distribution of stars like our own Sun. The farthest galaxies can only be studied in the infrared. Their light has been shifted to these long wavelengths by the expansion of the universe.
Close to Paranal is a small mountain peak with an isolated building on top. Inside this building is the 4.1-meter Vista telescope. It was built in the United Kingdom, ESO's 10th member state.
For now, Vista only does infrared. It uses a giant camera weighing as much as a pickup truck. And yes, Vista offers unprecedented vistas of the infrared universe.
ESO has been doing optical astronomy since its birth 50 years ago. And infrared astronomy for about 30 years.
But there are more registers to the cosmic symphony. 5,000 meters above sea level, high in the Chilean Andes, is the Chajnantor Plateau. Astronomy doesn't go higher than this.
Chajnantor is home to ALMA, the Atacama Large Millimeter Submillimeter Array.
ALMA is still under construction, at a site that is so hostile that it's even hard to breathe.
With just 10 of the 66 antennas in place, ALMA made its first observations in the autumn of 2011. Millimeter waves from space. To observe them, you need to be high and dry. Chajnantor is one of the best places in the world for this. Clouds of cold gas and dark dust become visible in a pair of colliding galaxies. This is not where stars are born, but where they are conceived. And these spiral waves in the outflow of a dying star, could they be due to an orbiting planet? By changing the way we look, we're closing in on the origins of planets, stars and galaxies, on the full symphony of the cosmos.
This is Dr. J, signing off from this special episode of the ESOcast. Join me again next time for another cosmic adventure.